Hello. Hi, my name is Jason, and this is Lance. And we have known each other for over 20 years. Lance was actually my mentor when I was working on my master's degree back in 2004. And we've stayed in touch. And more recently, we've been passing files and ideas and sculptures and all kinds of sort of collaborative works back and forth from Delaware to Michigan and back. In 2017, we began to discuss the promise of big data coupled with the loss and sense of distance that accompanies the digital age. So we decided to engage with cyberspace, collaborating with social media, satellite images, and topographies, and the code of search engines to evolve forums that reflect on access to information captured from afar. Considering some recent digital projects like Rome in a Day, in which computer scientists constructed a 3D model of Rome generated from thousands of photographs that tourists posted on Flickr. How can a failure to perfectly recreate the world tell us something or show us information that we had not expected to find?
Where information might be found in the ground and not the figure itself, maybe found in the blank, uncaptured spaces that become not a mapping of the world, but a mapping of a kind of collective conscious of how we are taught to look at the world. In projects like Rome in a Day, you get the wow of big data, crowdsourcing, and digital stitching and reconstruction, but what you're really getting is an extraordinary mapping of how and where we are taught to look. Just to note, each of these inverted tetrahedron shapes identifies the location and direction of a human holding a camera, and the programmers are triangulating this information to find three-dimensional space. Yeah. Oh, there's more. Wait, yeah. We contacted the computer vision engineers at the University of Washington and Cornell. Noah Snavely was especially helpful at this stage, who helped to develop the algorithms for photogrammetry. Their goal, and the universal goal of engineers, was to perfect the software and achieve models of high detail and accuracy. What we discovered and what captured our interest was the way that the models subtly revealed where people have chosen to focus their attention. What is every bit as interesting as the spaces captured are the spaces that are not captured. We first worked with a model generated of the Colosseum. With the huge number of pictures scavenged to reconstruct the building, it is fascinating to see the rendering has no back, and the Colosseum is a circle. Thinking through the facade of Notre Dame, we were struck by how much of that building is missing. The point cloud generated from tourist photographs provides empirical evidence that most visitors photograph the historic site from nearly the same vantage point, from a street level, straight on, looking at the entryway. When stitched together, the 64,000 square foot cathedral was reduced to a wafer-thin surface. In fact, to generate the image you're seeing here, we had to extrude the surface into space to give it volume to be able to see it at all. The interior of the Pantheon was reduced to half of a hemisphere. Again, it would appear that visitors entered the historic site, took nearly the same ubiquitous photograph, then exited the dome. This would imply that we are programmed to capture spaces and places following an algorithm of our own. An experiential trigger. I am standing in a very special place. I should capture this moment, standing right here at this time from eye level. Recently, we have been discussing between ourselves that we were tapping into an early 3D modeling version of artificial intelligence, a kind of crowdsourcing to build a form that could not have been realized by a single individual.
All right. So our contribution to the project can be found when the fragmented digital models become physical objects once more. In the attempt to encourage these objects to speak to their emptiness, we have worked to draw the absent spaces out and bring them back into 3D space. In essence, making 3D prints of the data, theorizing that it is difficult to imagine or feel empty space when viewing something on the screen. That to know empty space, it must have to be experienced in relation to the body. We wondered what were the material, scale, and other very physical conditions that would get at the impact that these virtual files had on our own imagination. This is easier said than done. We were originally drawn to Roman-a-Day because of the ethereal and intangible nature of the point clouds themselves. They're fragile, they're haunting, they defy physics. They have little connection to the corporeal. What happens when we reintroduce laws of the natural world? We must provide rules of our own. In this case, scaffolding is generated to support the 100 micron thin object. So this is like 1/10 of a millimeter thick. So in order to keep that intact, we had to build scaffolding to keep it in place, otherwise it would just crumble. And the work starts to cycle back to engineering and creative problem solving. So this is the attraction, the creativity of figuring out how to actually output the virtual back into the physical became a manageable problem once again, and perhaps began to supersede the power of the ghostly algorithmic dots in space. This back and forth between the virtual and physical is at the core of our sculptural investigation. In every case, there are subtle formal issues that come out of the process of photogrammetry, of generating a usable mesh that corresponds to the point cloud, making the file and object fit to 3D print or to carve, and a discussion of how it will ultimately exist in the physical world. Scale becomes a new and welcomed question. In theory, these files that we generate can be manufactured at any scale using any material. This allows us to consider what captured our imaginations in the very first place, and to ask how we might best draw that out of a sculptural object. And then gravity and physics return once more. So the thin facade of Notre Dame must lean against the wall for support. Again, it cannot stand on its own. So architecture in this case becomes recognized as a frail object. This is about 8 feet tall in my studio. Where the algorithms were needed to calculate height, distance, and the location of each unique photographer, now software is needed to communicate with robotic machines to convey points in space within a block of solid material. The G-code from the computer numerical control software speaks directly to the CNC mill and dictates Cartesian coordinates, feeds, which is how fast the tool is moving, in inches per second, and speeds, which is how many revolutions per minute a sharp end mill is rotating. The two combined will remove the material efficiently and reveal our form within. There's a calculation of feed, like the feed rate divided by the revolutions per minute times the number of flutes or cutters. So you can get down into the minutia of math to really refine the process, make it the most efficient, and remove physical chunks of material without it bogging down the machine or damaging the bit. So 2-axis, 3-axis, 4-axis, and even 5-axis machines and their inherent limitations determine the ultimate form of the object and the depth of the cuts. The material choice that we decide to use determines how the files are laid out for the machines themselves. See you again.
Curved surfaces must be broken into parts that comply with X, Y, and Z coordinates and perpendicular tool paths. The generally geometric and rectangular forms of commercial products must be considered again in organic form. And again, determining how the sculptures will actually stand and connect in gravitational space once they're brought back into the world. This is about 4 feet tall and will eventually be 9 feet long. The familiar can become uncanny through distortion, scale, and surface. In this piece, Jason and I created our initial photogrammetric model from shots taken of Mount Rushmore in Google Earth, attempting to push that notion of digital distance to the maximum by essentially taking pictures of pictures of pictures, distorting the 3D model to carve from many slices of dense foam, and pushing the machines to the limits of their capabilities. The final bits of the model that were too small and detailed to be carved out by the CNC machine were 3D printed. Again, noting the capacity to cut, slice, and build with exacting precision. Finally, we kind of are trying to wonder what kind of digital ruin might outlast the original ruin. In some speculative future, will these incomplete virtual models be all that is left to remember the original, that dream of techno-utopic perfect virtual mimesis? This back and forth between the virtual and the physical, how we get information into the computer and how we get objects out of digital space seems rich, with the possibility of considering how to translate subtle information and hidden details of form where new content might be found. I think I'm going to end it there.
Yeah. Thank you.
All right. All right, cool.